Now we'll talk about when you should use the flyweight design pattern. You should really only be using the flyweight design pattern under some specific conditions because it might not be necessary or even optimal. You should use it when there are a large amount of similar objects that are expensive to store, and when the memory footprint of the program is really high for the device that the program is running on. So you could see that being useful in certain games where they store things where it uses a high amount of memory and it stores things that are very similar. And objects, it should be used when there's a lot of objects that can be duplicated and shared between similar objects. So the way that the flyweight design pattern works, I put Mario and Luigi on the screen. It's because, they are very similar in many ways. They could be used as like the same character with slight edits for the fact that Mario's red, Luigi is taller, and you could save a lot of memory that way if you share those attributes. And it also is important that the object identity doesn't matter because these things are shared, so the identity could cause some issues. So here's some of the advantages and disadvantages of using the flyweight design pattern. The flyweight design pattern improves performance by reducing the amount of objects in the program, and it also reduces RAM usage by sharing those intrinsic properties between the objects. But there are some disadvantages as well. There has to be a lot of shareable properties like we've discussed, and there has to be no real memory constraint. I mean, if there is no memory constraint, it's going to be overkill. And it also makes the code complex and more difficult to implement overall.